Okay, hello, Julia lovers. Welcome to exciting this Falra.jl distribution computing with AI source code generation. And I'm Chalo, and it's my partner is Bowen. We come from Taiwan. Sorry. Okay, sorry. And it's good to be here and have the opportunity to share the idea with all of you. And we have been collaborating with the Taiwanese government on big data analysis for the environmental IoT. Through the data analysis and visualization, we have to help government agency identify and recover 11 million US dollars from factory causing the air pollution. So in our environmental project, we encounter the challenge of producing a 6-year PM 2.5 analyzed report from 60 TB data. With a single computer, it would take 100 days. Additionally, the existing data clean source code was challenged to rewrite a distributed computing architecture. So to overcome this problem, we developed the Falra.jl, which reduced the data clean time from 100 days to just 1 day. So here we have the 3 decided principles for Falra.jl. The first one is simple. There's no need to write a special source code from distributing computing. Simply create a state-alone main.jl program is enough. And the second is auto. The source code automatically generated and deployed by AI. And the third one is free. Falra.jl is an open source. Let's use OpenAI's free trial API for source code generation. Additionally, the GitHub actions provide everyone with a 20 free virtual machine. So here we have developed a website called Barang.ai, which running the Falra through an AI chatbot. So you can see, after Barang says, "Hello, Julia lovers, I'm Barang," we can start to chat with her. So, Barang, please download and unzip our environmental data analysis sample from Google Drive. Okay, so you can use your own sample data for me. She's using her default sample data and dynamically write a Julia program to download a zip file from the Google Drive. Then write another program to unzip it. But she's not just about generate source code. She can also run it immediately and show users the result. So let me tell the Barang, let's preview the first 5 rows to understand the data format to me. Oh, wow, it's cool. We can see the CSV file contains the columns for device ID, long, late, time, and value. So Barang, to ensure no data loss, we must write the code to count all CSV rows from our PM 2.5 sensors supply. Okay, you can see it's mistakes. So let's see, the source code generated from counting rows is missing the data frame package. So we may need to tell her, Barang debug. Okay, it's wonderful. Now she's correct. We can see the row numbers of all the CSV files. So Barang, all steps, including the file download, decompressions, and count of the CSV rows, must be in one single main.jl with a document ID argument. Okay, it appears that we need to provide a document ID as an argument for her. to taste. So Baran, please write a test program to test it. Okay, we can see. So please show me the result of the CSV file.
Wow, it's good. Okay, Baran, in order to distribute main.jl across 20 virtual machines using GitHub Actions, we must create a GitHub repository named test123. Great. Now Baran should create a GitHub Actions YAML script for distributed computing. This will instruct GitHub to process different zip files in parallel across 20 different virtual machines. Okay, Baran, please write a main.yaml GitHub action script for distributed computing. This script is maximum of 20 parallel virtual machines. It's processing 3 .id zip files. The script clones our counting program repository, test123. It sets up the Julia runtime environment using version 1.9 on each virtual machine. The necessary packages are then installed. After that, main.jl is executed on each virtual machine. Finally, the counting results are merged and output in an all result.csv. Baran, please upload 2 files, main.jl and main.yaml, to the GitHub repository. Okay, we can see the file is already on the GitHub. Baran, please dispatch main.yaml to run it. We can visit GitHub website and clearly see 3 different virtual machines running in parallel. These machines handle everything from installing the operating system and the Julia runtime to running the counting program. In the end, they consolidate all results into one CSV file for us. Finally, Baran, please download artifacts of GitHub Actions. Okay, so we can see the final results consolidated into one single CSV file. This can be used to verify whether all the PM2.5 sensors have been functioning properly. Our code doesn't need a vacation, but you do. If you scan the QR code on the left side, you can access the public source code for the Falra project. And if you're interested in interacting with Baran.ai, please scan the QR code on the right and submit your email for a free trial. That's our sharing. Thank you so much.
Do we have any questions?
So at one point in time, you showed that there was like an error. And of course, you know, the OpenAI and the ChatGPT interface, it's just open to hallucination.
Yes.
So that's one element, and you try to kind of like guide it through somehow.
Yes.
So how often would you come across this? And also, you could have a program that's syntactically correct. It's got everything, but then logically it's wrong. So how do you manage that?
Okay, thank you. Actually, we need to divide and conquer the big problems. So to prevent OpenAI tell us the wrong answer, and if we can write a very small piece of source code, like a function, then we write another function to test it by AI, it will more correct than a larger function. Yeah.
All right.
Is the GitHub action hosted by itself or by GitHub?
The question is the GitHub action that you showed hosted by GitHub?
Yes, the GitHub Actions offers 20 free virtual machines, self-hosted, and you can also host your own GitHub Action runtime in Google Cloud Platform or other like AWS platform. That both will be okay.
I think any remainder questions we can take offline. And thank you for the wonderful talk.
Thank you.
Let's thank the speakers, please.